Hello and welcome to today's lesson on stopping distance. We will begin by understanding what stopping distance is and its two main components, thinking distance and braking distance. Next, we will explore how momentum and forces relate to stopping distance, including the impact of a vehicle's speed on the distance required to stop completely. So far, you are familiar with examples of safety features. These safety features are designed to reduce the risk of accidents or minimize the effects of a collision. Building on this foundation, we can now delve into stopping distance. This concept will enhance our understanding of physics by linking momentum and forces to real-world scenarios, helping us appreciate the importance of speed and braking in vehicle safety. Stopping distance is the total distance a vehicle travels from the moment a driver perceives a hazard until the vehicle comes to a complete stop. This consists of two main components. Thinking distance is the distance the vehicle travels from the moment the driver sees a hazard until they apply the brakes. Reacting to a hazard takes a certain amount of time, usually called reaction time, and during this period, the vehicle continues to move forward. We'll expand on this in subsequent lessons. Braking distance is the distance the vehicle travels after the driver has applied the brakes, up to the point where it comes to a complete stop. This distance depends on several factors, including the speed of the vehicle, road conditions, and the efficiency of the braking system. As with thinking distance, we'll expand on braking distance in our next lessons. Let's explore how momentum and forces are related to stopping distance. When a vehicle is moving, it possesses momentum. You'll recall that momentum is defined as the product of the vehicle's mass and its velocity. Momentum equals mass times velocity. So how does this connect to stopping distance? A vehicle traveling at a higher speed has more momentum compared to one traveling at a lower speed. To stop the vehicle, its momentum must be reduced to zero. This is achieved by applying a braking force, which acts to decelerate the vehicle over a period of time. The braking force applied effectively reduces the vehicle's momentum. Mathematically, this can be represented as force equals change in momentum over time. If the braking force is constant, a vehicle with higher momentum, due to higher speed, will take more time to reduce its momentum to zero. As a result, the vehicle will cover a greater distance during the braking process. In simpler terms, the greater the initial speed of the vehicle, the longer the distance it will travel before coming to a complete stop, assuming the braking force remains the same. To make these ideas clearer, consider a graph where the x-axis represents time and the y-axis represents velocity. A driver notices a hazard and decides to stop the vehicle. The vehicle continues to move during the thinking distance as no brakes are yet applied and the velocity remains constant. Once the brakes are applied, the vehicle decelerates and its velocity drops to zero during the braking distance. Knowing about stopping distances can help drivers make safer decisions. For instance, maintaining a safe following distance from the vehicle in front allows you sufficient time and space to react and stop if necessary. Next time you're on the road, remember how important it is to consider the speed of the car you're in and the distance between you and the car ahead. These considerations can significantly enhance overall road safety. In today's lesson, we delved into the concept of stopping distance, which is the total distance a vehicle travels from the moment a driver perceives a hazard until the vehicle stops completely. This is composed of two key components, thinking distance and braking distance. We explored how momentum and forces influence stopping distance, noting that a vehicle with higher speed has more momentum and therefore requires a longer distance to stop. We used a graph to visualize how velocity changes during the thinking and braking phases. Watch the rest of the GCSE Physics course at Sophos Education.